Hi, I'm Peter Sonic, and today I will talk about extending syslog ng in Python. Uh, I'm coming from Hungary. I'm evangelist at One Identity. Syslog ng is upstream developer. I'm doing syslog ng packaging support and advocacy. First, I will give you a quick introduction.
To hold the microphone in front of you.
Oh, okay. First, I will give you a quick introduction to syslog ng and its four major roles. And show you how to configure syslog ng for Python, and a few simple source code examples how you can code in Python for syslog ng. So, what is logging? It's a recording of events like an SSH login. You can see many of these messages in varlog in the varlog directory. Syslog ng in an enhanced logging daemon with a strong focus on portability and high performance central log collection. It was originally developed in C. So why Python? As Python is actually slower than C. On the other hand, it makes development a lot more easy and flexible, and you don't need a dedicated development environment like with C. It's just a text editor, and you are ready to go. And even a sysadmin like myself can extend syslog ng with new functionality. There are four major roles of syslog ng. It's collecting messages, processing them, filtering them, and finally storing them either locally or to another destination. The first role is data collection. There are a wide variety of platform-specific sources supported like devlog, journal, sunstreams. As a central log collector, it knows the legacy and the new syslog protocol over UDP, TCP, and encrypted connections. But the absolute jolly joker source is the Python source, as this way you can add easily just about anything, like an HTTP server to collect log messages, or fetch messages from Amazon CloudFetch using the Python API, or adding a Kafka source without really too much effort. The next role is processing. You can classify, normalize, and structure log messages with built-in parsers. You can rewrite log messages, and you don't have to think about falsifying messages here, but for example, anonymization as required by many different compliance regulations. You can reformat messages. For example, if your destination needs JSON, you can turn your messages to JSON. You can enrich messages using GIP, or add additional fields on message content. And the Python parser can do practically all of the above I've mentioned, and you can also use it to enrich log messages from external databases, and also do filtering, which also brings us immediately to our next topic, filtering, which has two main uses. One is discarding surplus log messages, and the other one is message routing. So you can make sure that, for example, all authentication-related messages reach your log analysis systems. It can be based on many possibilities like message content, parameters, different macros, using comparisons, wildcards, and filtering functions, and best of all, any of these can be combined using Boolean operators to make really complex filtering. Finally, you have to store your log messages somewhere. Traditionally, syslog messages were stored locally into flat files or sent over to a central location using the syslog protocol and saved to flat files over there. Over the times, many different destinations were added, like SQL, different big data destinations like Hadoop, Elasticsearch, and now we also have Python destination, so you can easily write support for just about anything. Personally, I did an MQTT destination, which is already used in production many places. Let's talk a few words about log messages. If you look at a typical log message, you see that it's date, a host name, and some text after it, like this SSH login message. If you look at the text part, you see that it's an almost complete English sentence with some variable parts in it. It's pretty easy to be read by a human, but you will have quite tough time if you want to create alerts and reports automatically from these kind of messages. The solution for this is to use structured logging, in which case events are represented as name value pairs. For example, the SSH login I've shown you in the previous slide can be described as an application name, a username, and a source IP address. And syslog-ng has name value pairs right from the beginning, the date, facility, priority, and so on. And parsers can turn many unstructured and some structured data also into name value pairs. And the Python bindings of syslog-ng support name value pairs as well. So before going deeper into Python, a tricky question. Without looking into next slide, what do you think? Which is the most used syslog-ng version? Some pointers. Our most popular distribution has 3.5. The current version is 3.19. What do you think? Well, close. It's 1.6. As I don't think there are any other computers running in this number, so it's 1.6 and over 100 million Kindle devices. So back to more serious topics, configuring syslog-ng. So my initial advice is don't panic. Configuring syslog-ng looks a difficult task at first, but it's really simple. It has a pipeline model where there are many different building blocks, like sources, where you collect messages, destinations, where you store messages, filters, parsers, and so on. And these building blocks are connected together using log statements. Here you can see a quick example. Oops. It starts with a version number. You can include extra other configurations. You can comment your configuration, define some global options, so you don't have to specify each time how many lines to write together, but configure it once, and you can override it later on. Then here are the different building blocks I mentioned: a source, a destination, a filter. These define warlog messages, and you connect all of these together in a log statements: the source, the filter, and the destination. So how Python is coming here? The Python bindings always have two parts: a configuration part and the code part. Usually the configuration part has just a single mandatory option, the class name, what you call from syslog-ng. And you can also pass many parameters and also pass parameters to your Python code. So you don't have to hard code everything into Python, but have a generic Python code which you parameter from your syslog-ng configuration. The code itself can be stored in the syslog-ng configuration in a Python block, or stored in external files. Like you can put it just anywhere a script and call it, or create a proper Python module and use that. Which Python versions are supported? It really depends on, at the time, compiling syslog-ng, so it supports one version at a time. It can be compiled with 2.7 or 3.4 or later. And in any packages I maintain, I compile it with Python 3. Let's start with the Python destination, even if it's logically at the end of the chain, but this was the first one implemented within syslog-ng. On the Python side, the only method you have to implement is send, which is actually sending your message to somewhere. And you can pass name value pairs from syslog-ng to Python in two ways. If you don't define what to send to Python in the configuration, then there is an object containing all of the different name value pairs from syslog-ng, or you can define what values to send to the destination, and in that case all those name value pairs are in a dict. There are many optional possibilities configuring the Python destination. You can define things like a disk buffer, so no messages are lost if the Python destination is busy. And if you want to write real robust code, then you don't use only a single send method, but do proper initialization, init, which are called when syslog-ng started or reloaded, or and use open and close, which are called from syslog-ng when syslog-ng started, reloaded, or when sending the message failed. Here is a very simple Python destination. It's practically a file destination re-implemented in Python. As you can see, here is just a single class option in the Python destination, the same as here in the Python code. We have a log statement which connects the default source to the Python destination, and here is the Python code inline the syslog-ng configuration. As you can see, the class name is the same as defined up there, and we have a single send method which has all of the code, the file name hard-coded, picking a single name value pair through the message object, writing it into to the disk, and closing the file. Of course, if you want to do something production ready, then you better use all of the optional methods I mentioned on the previous slide. But this also works, and good something to get started with. The next one is the Python parser, where we in the Python code only the parse method is mandatory, and here name value pairs are available only through an object, and here you can create new name value pairs as well using this object. In the sample code on the next slide, I will parse this log message. This is generated by logcan. That's a tool for syslog-ng for testing and benchmarking, and it has this beautiful message format. Here you can see the configuration part for the Python parser. Here is the parser defined. As you can see, the class name is here, and here we also have an optional thing. The regular expression parsing the message on the previous slide is passed here as an object passed here as an option to the Python code. And here is a log statement which starts with a network collector, the Python parser, and the destination file, where we also use a message template with the name value pairs extracted from the previous log message by using the Python code. And here is the actual Python code using this, importing the regular expression library and the class we defined also in the configuration. Here we also use the init method, where we initialize the regular expression parser and also start the counter. I'm showing this as the Python code is started together with syslog-ng, and it's running constantly as long as syslog-ng is running or reloaded. So you can create variables, create a counter like this, and you can refer to it on later log messages. So if Python is not started each time a new message arrived. And here is the code part. The init method is usually empty, but I put it here. And here is the parser part. We pick the message from the log message object, run the regular expression parser in it, create new name value pairs to the log message object, also create a counter name value pair and increase the counter here. Finally, we also have a Python source. This was released just recently, probably 2 months ago or 3. It has very few optional configuration possibilities like time zone handling. Name value pairs are handled here also through an object, and it has 2 modes. You can write complete server application for collecting messages, or you can use it as a fetcher where syslog-ng itself handles the event loop. In my example, I used the server part, and the server has 2 mandatory methods, the run method and the request exit. The later one is necessary to quit from our own event loop. Here is the configuration part of the simple Python source. Here we define the class name and pass a few dummy options, file destination, and a log statement which combines the 2 together, so the Python source and the destination file. And here is the actual Python code for the Python source. This source simply generates log messages like crazy as long as syslog-ng is running, so it's an easy way to fill up your hard drive quickly. I tested just for numbers. Syslog-ng on my laptop, syslog-ng can handle about 900,000 messages, and with this Python source, it handled about 300,000 messages. So it's still quite a nice number. To use the Python source, you need to import a few classes from syslog-ng, and in the class the class needs to descend it from the log source class. In the initialization part, we just simply print the options I defined and set the exit variable to false. This is used by the request exit method and here in the event loop of my Python code to exit once syslog-ng is reloaded or stopped. And here in this part we generate log messages, just very simple text message, and send it to syslog-ng. And here is a preview which was merged just recently into syslog-ng and will be available in the next release. This way, debugging Python code in syslog-ng will be easier as by using the logger method of syslog-ng, you can create log messages from the Python code for syslog-ng appearing on the internal source, so you can see you can follow what's going on in your Python code as a log message within syslog-ng, or if you start it in the foreground, then these messages are printed on your terminal window. These were quite simple examples, but there are more complex examples available on my blog, an MQTT destination, a few parsers, and an HTTP source. You can check these out for more complex examples. If you want to learn more about syslog-ng and try it out, either just syslog-ng or the Python bindings, you can find more information on syslog-ng.org. The source code is on GitHub, and we also have an issue tracker there if you run into any problems. And you can ask questions on our mailing list or on Jitter. And we have probably 2 minutes for questions. If you have any. Sorry?
Can you send messages to Kinesis from syslog-ng, or it's not implemented yet?
To where? What I mentioned here is a collector, so it can pull messages from there. I guess if it has an API, then it's not yet implemented, but it shouldn't be difficult to implement it. It's open source, and actually the earlier Python bindings are already in distributions, but if it's too early syslog-ng in the distros, then there are third-party package repositories with up-to-date packages and with Python bindings enabled, so you can test it. Any questions? Okay, thank you.